Hello everyone, you're welcome back to my channel. If you are new here, you are warmly welcome. I hope you enjoy this session. We've been considering the IGCSE syllabus for some time now, so you would want to have a look at some of the topics we've considered to get a better understanding and then continue from there. We are still talking about forces, and this time around we want to consider circular motion. We've all experienced or seen circular motion in action before, being it ourselves or objects that we see undergoing circular motion. Examples of circular motion includes a rotating fan, a moving car's wheels, a stone tied to a string and being swung in a circular fashion, a car negotiating a bend. But the question is, what enables an object to undergo circular motion? Well, according to Newton's first law of motion, if an object is moving in a straight line, it continues to do so unless an external force acts on it. So, like we considered earlier, if an object is at rest or it is moving in a straight line, it will continue to do so unless an external force or a force external to the body acts on that object. It wouldn't change direction, it wouldn't deviate from that straight line unless an external force acts on it. Now, based on that premise, if an object should move in a circular path that is not in a straight line, then you guessed it, there should be some force external to the body acting on that body to be able to cause it to move in that circular path. So if we consider the diagrams that we have here, for this first diagram we can picture it to be a stone tied to a string and being swung around in a circle. The object was initially at A, and from this diagram we can see the direction of motion of the object was at A. But the object after some time is found at B. We see the direction here indicated by the arrow, and at B we see the direction of motion of the object. It is clearly not moving in a straight line. By moving from A to B, we see a change in direction of the motion of the object. We'll put more meaning into the second diagram in a bit. But by moving from A to B, then it stands to reason, based on Newton's first law of motion, that there is a force external to this body that is causing it to move in a circular path, but not in a straight line. The question then is, where does this external force come from? Well, from this diagram, the string is what produces this external force acting on the stone to help it move in a circular manner. The string has tensional force, or there is tension in the string. And the tension in the string is what pulls in on the stone to cause it to move in a circular manner. So we see a force external to the stone, and we see that beautifully shown in the diagram. An arrow is indicated on the string, and these arrows are directed away from the stone, acting towards the center of the circle. In the case of a car that is negotiating a bend, or a car undergoing circular motion, there is friction between the tires of the car and the road on which it moves. That frictional force acting is what produces the external force to enable the car to undergo circular motion. So then, what is the point we want to take note of? For an object to continue to move in a circle, there should be a force external to it acting on the object. And that force is usually directed towards the center of the motion. The inward force that causes the object to move in a circle is referred to as centripetal force. And centripetal force is directed towards the center of the motion, as depicted here. Centripetal force depends on a number of factors. It depends on the speed at which the object is moving, the radius of the object from the center, the mass of the object. Centripetal force increases if 1. The speed of the object increases, 2. The mass of the object increases, and 3. Radius decreases. There is actually an equation or a relation that ties these things together. But that's beyond the scope of the syllabus, so we are not going to dive into it. For a body undergoing uniform circular motion, a uniform circular motion means that the object has steady speed as it moves. Its speed does not increase for a body undergoing uniform circular motion. But when we look at this diagram here, we notice something, that the direction of the object keeps changing. If a tangent is drawn to the circle at point A, we see the direction of motion of the object. At point B, a tangent is drawn to the circle. Again, we see the direction of motion of the object at point B. Clearly, the object's direction keeps changing. It doesn't remain the same. In this case, speed is not changing, but direction is, which means that velocity is changing. Velocity can change when speed changes or direction changes. A change in velocity would mean an acceleration. And this acceleration is provided by the centripetal force. And as a result, we refer to this acceleration as centripetal acceleration, since the force is referred to as centripetal force. And these are a few things you would want to keep in mind when it comes to circular motion as stated in the syllabus. I hope you enjoyed this short presentation. We'll continue next time on our discussion on forces. We'll be looking at moments of a force. Please be sure to subscribe, like the video, leave a comment in the section below. If you have any questions you want addressed, please feel free to leave it in the comment section below.